In Module 2, Lesson 18, we're going to write, evaluate, and find equivalent expressions with rational numbers. Our first real-life problem is a comparison of cell phone plans. John's father has asked John to compare several different cell phone plans and identify which plan will be the least expensive for the family. Using the information in the table, we're going to answer the questions below. All members of the family may not want identical plans. Therefore, we will let X represent the number of phone lines, Y will represent the number of phone lines with unlimited texting, and Z will represent the number of phone lines with internet access. The first thing we need to do is write expressions for each of the cell phone plans. So we'll actually go across each row to write the expression. Company A has a $70 monthly fee, and then $20 per phone line, so that is 20 times X, $15 per phone line for unlimited texting, and we're representing that with Y, so 15 times Y, and then finally $15 per phone line for internet access, and we'll represent that as 15 times Z. Company B has a $90 monthly fee and $15 per phone line, so 15 times X, $10 per line for unlimited texting, so that is 10 times Y, and finally $20 per line for internet access, and that would be 20 times Z. And then Company C has a $200 monthly fee, and the only other charge that they have is $10 per phone line, so 10x. The texting and the internet access are all included in the monthly fee, so we have no charge for any of them. Next in our search, we're going to need to take those expressions and use them in a number of different situations. So we'll look at situation A. In situation A, 4 people want a phone line, 4 people want unlimited texting, and the family needs 2 internet lines. So we'll be using those 3 expressions that we created up above for Company A, Company B, and Company C, and we will substitute in the information that they've given us in Part A. So in looking at the expression for Company A, and this is the expression that we wrote up above, 70 plus 20x plus 15y plus 15z. Now what we'll do is substitute for x, y, and z in the expression, and then we can solve. So 70 remains the same. 20 times x, and x represented the number of phone lines. So in this case, 4 people want a phone line. So we'll be doing 20 times 4. We can represent the multiplication, remember, without any symbol. And 15 times y, y represented unlimited texting. And 4 people want unlimited texting. So we'll do 15 times 4. And finally, 15 times z and z represents the number of internet access lines. In this case, the family only needs 2 internet lines, so we'll put 2 in parentheses. And then we can further simplify and solve, which would be 70 plus 20 times 4, which is 80, plus 15 times 4, which is 60, plus 15 times 2, which is 30, and 70 plus 80 plus 60 plus 30 is $240. Looking then at Company B, we have the $90 fixed fee plus 15 times 4, because our x and y and z values in each of these situations would remain the same for the whole situation. 10 times y, where y was actually the number of lines with unlimited texting, and 20 times z, which was the number of internet access lines. Again, we do our calculations. 15 times 4 is 60. 10 times 4 is 40. 20 times 2 is 40. And so the value or the cost of this plan would be $230. And finally, with Company C, we'll have 200 for the flat fee plus 10 times each line. And we need 4 phone lines in this case, which would be 200 plus 40, which is 240. And when we evaluate which cell phone company John's family should use, in this situation, Company B would be the better value because it is slightly less money. Situation B, we will start off with the same expressions that we created at the beginning, and then we'll substitute differently. So in situation B, 4 people want a phone line, 4 people want unlimited texting, and all 4 people want internet lines. So for each of our variables, we will replace with 4. Then when we evaluate, we would have 70 plus 80 plus 60 plus 60. Which is 270 for Company A. Company B, 90 plus 60 plus 40 plus 80 is 270. And finally, for Company C, 200 plus 40 is 240. So in situation B, John's family should choose Company C because it is the least expensive for those options. And in our final situation, we have 2 people who want a phone line, 2 people who want unlimited texting, and the family needs 2 internet lines. So each of our variables will be replaced with 2. So we find under situation C that the best value would be Company A because it has the least cost. Please remember, these are expressions that we were writing, so there are no equal signs. Moving on to example 2, 3 friends went to the movies and each purchased a medium-sized popcorn for P dollars and a small soft drink for S dollars. They're asking us, first of all, to write the expression that represents the total amount of money that the 3 friends spent at the concession stand, so all 3 of them together. And there are a variety of different ways we could write that, but I'll write it as 3 times the quantity P plus S. In other words, we add up the cost of the popcorn and the soft drink together, and then we multiply it times 3, since there were 3 friends. Next, in Part B, they tell us that the concession stand charges $6.50 for popcorn and $4 for a small soft drink. And they want to know how much would the 3 friends spend altogether. So we'll substitute 3 times $6.50 plus $4. And then to solve, 3 times $10.50 is $31.50. Our final example is example 3. And they asked us to complete the table by writing equivalent expressions to the given expression and evaluating each expression with the given values. Looking at the example, the first expression that we have is 4 times the quantity x plus 2y. And we can see that they've asked us to make x equal 2 and y equal -1. We substituted into that expression and solved and got 0. Another way to write 4 times the quantity x plus 2y would be to distribute the 4, since it is being multiplied times both x and 2y. So if we multiply 4 times x, we get 4x. And if we multiply 4 times 2y, we would multiply the numbers and keep the variable. 4 times 2 is 8 times y. And again, we would substitute x being 2, y being -1, and then solve and find that that value is also 0. If they are equivalent expressions, when you solve or evaluate these, they have to have the same answer. In the third example, all we really did was took 8y and split it into 4y and 4y. So we have 4x plus 4y plus 4y, because 4y and 4y more is 8y. Again, we substituted in, and when we solved, got 0. Those are 3 equivalent expressions. So if we look at number 1, we have an original expression of 5 times the quantity 3 minus 4y. So to write an equivalent expression, we can distribute, just like we did in the first example. And 5 times 3 would be 15. Then we will keep the minus sign or subtraction sign, whatever you want to call that there, in between. And multiply 5 times 4y, which is 20y. And finally, in our final example, we can take that 20y and split it apart. But we need to remember, when we split that apart, let's try something over here just to prove it. 15 minus 20y is actually 15. Let's change this to addition, just like we've done in the past. 15 plus -20y. And that will help us to rewrite the expression, because now we can see that this is -20 times y. And if we want to split that apart, we have to have -10y and -10y. And then if we continue on to solve, in the first expression we would have 5 times 3 minus 4 times y, and y is 1, so 4 times 1 is 4. which is 5 times negative 1, which is negative 5. Next expression, 15 minus 20y. Y, remember, is 1, so 20 times 1 is 20. And 15 minus 20 is negative 5. And then our final expression, which certainly does look more complicated, would be 15 plus negative 10 times y. Y is 1, so that's negative 10. Plus, again, negative 10. And if we add 15 and negative 10 and another negative 10, we would get negative 5. In question 2, we have negative 3x plus 12y. Well, I'm going to factor out a 3 because the greatest common factor of 3 and 12 is 3. So if I take 3 and factor it out, in order to get negative 3x, we would have to multiply by negative x. And just in case we're not quite there in your understanding, let's call it negative 1x, because 3 times negative 1 is negative 3, and the x stays the same. Keep our plus sign, and then remember we factored out a 3, so 3 times 4 equals 12. And so our second term inside the expression would be 4y. If you're not certain, go back and use the distributive property to see if you get back to this expression or not. 3 times negative 1x would be negative 3x, and 3 times 4y would be 12y. And then, in our last column, and certainly there are other ways to do this, but in our last column, if we are looking at negative 3x, that means negative x plus negative x plus negative x, and then 12y could be 4y plus 4y plus 4y. Again, we'll substitute and solve. And they've asked x to be 5 in this situation. So we have negative 3 times 5 plus 12 times negative 2, which is what they want y to be in this situation. Negative 3 times 5 is negative 15. And 12 times negative 2 is negative 24. And when we add those two together, we get negative 39. Checking our other expressions. 3 times negative 1 times 5. Let's just go ahead and solve right there. Negative 1 times 5 is negative 5. Plus 4 times y. And y is negative 2. So 4 times negative 2 is negative 8. Solving what's inside the parentheses first, negative 5 plus negative 8 is negative 13. So we're multiplying 3 times negative 13, which is negative 39. And our final version of the expression, negative x, which means negative 5, plus negative 5, plus negative 5, and y, we want to be negative 2. So 4 times negative 2 is negative 8. And we do that again, And we do that again. So when we add negative 5, negative 5, negative 5, that's negative 15, and negative 8 plus negative 8 plus negative 8 is negative 24. And added together, they are negative 39. And then in our last example, they've given us an expression on the right, negative 2x plus 10x minus 6y. The first thing we could do to rewrite this expression would be to combine our x's. If I have negative 2x plus 10x, combined, that would be 8x. I have a positive 10x and a negative 2x, and combined they are 8x. And 6y, which doesn't change. In our middle expression, 8 and 6 have a greatest common factor of 2. So I could factor out the 2, and then 2 times 4 equals 8. So we'll put inside the parentheses 4x, keep your minus sign, and 2 times 3 equals 6, so the other factor would be 3y. 2 times 4x would be 8x. 2 times 3y would be 6y, and there's a minus sign between them. Finally, we'll need to substitute, and our substitution numbers are not super easy either. We're doing 8 times negative 1/2, which is what they've asked us to make x equal, minus 6 times 1, which is 6, so we can leave that. 8 times negative 1/2 is negative 4, minus 6, which is negative 10. Doing our next version of the expression, 2 times 4 times x, 4 times x, which is negative 1/2, minus 3 times y, and y is 1, so minus 3. Working from the inside out, we need to multiply 4 times negative 1/2, which is negative 2, minus 3. Make sure you always rewrite what's inside the parentheses and all the rest of your expression. It'll be easy to lose track of numbers in these more difficult expressions. Inside the parentheses, negative 2 minus 3 is negative 5, and 2 times negative 5 is negative 10. And finally, in our last one, negative 2 times negative 1/2 plus 10 times negative 1/2 minus 6y, which is 6 because y is 1. Negative 2 times negative 1/2 is positive 1. Negative times a negative is a positive. And 10 times negative 1/2 is negative 5. Minus 6. And when we add those together, we find negative 10. In summary, an expression is a number or a letter which can be raised to a whole number exponent. We haven't done that yet, but it can be. An expression can be a product whose factors are any one of the entities described above. Factors can be a number or a letter, and those numbers and or letters can be raised to an exponent. Okay, so that's what this means. An expression can be a product whose factors are any one of these things, number, letter, and even including exponents. An expression can also be the sum and or difference of the products described above. To evaluate an expression, replace each variable with its corresponding numerical value And using the order of operations, the expression can be written as a single numerical value. Expressions are equivalent if they evaluate to the same number for every substitution of numbers into all the letters in each expression. So no matter what we choose for x or y or z, if you substitute into the different expressions and you always get the same value or the same answer, then they are equivalent.